Alright guys, welcome to this page of the notes, and again what we're doing is just taking a look at some of the different types of problems I can give you when asking you to do composite functions, and in this case not even composite functions but composite relations. So I've given you the relation f and the relation g, which is just a set of ordered pairs. Let's go ahead and run through these, finding f of g of x and then g of f of x. Now, we got some practice on the previous page, so I think we can probably work our way through these ones pretty quickly. Let's see what we get. We will do f of g of x first, and we'll just work our way through them. The first one I'm going to do is going to be f of g of 4, right? Because the first domain value I'm going to plug in is going to be a 4. Well, I plug in a 4, g gives me back a 3. I take that 3 and I'm going to plug it into f. There's my 3. I plug 3 into f, and f gives me back a negative 2. The next one is going to be f of g of 2, because that's my next domain value. Just working my way systematically through these so I don't forget any. I plug a 2 into g. G gives me back a negative 1. Let's take that negative 1 and plug it into f. There it is right there. I plug a negative 1 into f. F gives me back a negative 5 minus 5. The next one is going to be f of g of 9. Why a 9? Well, because 9 is my next domain value. Again, I'm just working my way through these ordered pairs so I don't forget any. 9 gets plugged into g. G gives me back a 4. I need to find 4 in my relation of f. There it is right there. I plug 4 into f, and f is going to give me back a 7. So f of g of 9 is going to be 7. The last one, f of g of 3. Why a 3? Well, because 3 is my last domain value. That's the last one I got to plug in. I plug a 3 into g. G gives me back a 10. Take that 10, plug it into the relation f. I plug it, there it is, 10 right there. I plug a 10 into f, and f gives me back an 8. All right, let's go ahead and do these for g of f of x. So the first one I'm going to do is I'm going to do g of f, and the first domain value I'm going to plug in is going to be a 3. All right, I plug that 3 into f. F gives me back a negative 2. I now need to find negative 2 in g. 4, 2, 9, 3. I don't have a negative 2, so this is undefined. Let's do the next one. G of f of negative 1. I plug a negative 1 into f. F gives me back a minus 5. I now need to find minus 5 in g to figure out what its range value is. 4, 2, 9, 3. I don't have a minus 5, so undefined. Next one, f of g of 4. Why? Well, because 4 is my next domain value. That's the next thing I'm going to plug into f. So 4 goes into f. F gives you back a 7. I need to find 7 in g. 4, 2, 9, 3. I don't have a 7 yet again. We are undefined, right? Doesn't exist. And my last one, g of f of 10. Okay, I plug a domain value of 10 into the function f. F gives me back an 8. I'm now going to plug that 8 into g. 4, 2, 9, 8. I don't have an ordered pair with a domain value of 8, which means it is undefined for my relation g. It turns out all of those wound up being undefined. Again, you could set up your domain and range values if you wanted to. This one's going to be kind of boring. The domain would be everything you plugged in. 4, 2, 9, and 3 would be my domain values for the composite function f of g of x. The range values would be negative 2, negative 5, 7, and 8. For the g of f of x, my domain values would be everything I plugged in. 3, negative 1, 4, and 10. But my range values are all going to be undefined. They don't actually have a corresponding range value because g of f of x does not exist. It's undefined. Guys, I hope that makes sense. Should be pretty straightforward and easy. When I give you relations, you'll just systematically work your way through them to make sure that you have gotten all of them. Head on over to the next page of notes, and I'll show you another way I could ask you to do these composite function problems. So I'll meet you over there.